ये तो सामने आता है.
So we want to find out the rate of reaction, or we want to monitor the rate of the reaction, because we want to check the factors that influence the rate of the reaction. And to check each factor, we should have a monitoring mechanism, that when we change that factor, how the rate varies. So normally there are two main methods to find out the rate of reaction. One is gas syringe method, and the other in your syllabus is loss in mass method. The gas syringe method, as the name indicates, involves a gas syringe. And when the gas syringe has come into the play, it means one of the product is gas. Okay, like metal and acid reaction always produce a gas if the metals are active. Metal carbonate and acid produce a gas, or ammonium compounds, ammonium nitrate, etc. when react with alkalis, they produce a gas. Or sometimes a decomposition reaction may yield a gas. So when gases are involved, easier it is. You have a gas syringe. And when you have a gas syringe, you can always find out how much gas is produced per unit of time. That will tell us about the pace. If the gas is produced very quickly, it means rate is very fast. And if the gas is sluggish and slow, it means you need to check factors, one or two factors, to improve the rate of a reaction. Okay, so you can find out gas syringe method. A little drying mean the flask may be round bottom flask mostly, or flat bottom one, and it is closed from here, and the gas syringe that measures in centimeter cube, easy soft plunger it has. When the gas is being produced, it comes right here, and you'll find out the plunger move backward. You can use the stopwatch to find out how much the time has actually taken to the gas syringe to reach to the filling level. Okay, the gas syringe needed, stopwatch needed, round bottom or flat bottom flask, it may be time and volume of the gas. Time, look at 0, volume 0, but time as increases in minutes in this case, the centimeter cubes are increasing. At a time you will find out the two readings are constant. It means those two readings, when it has become constant first time, it means the reaction is finished at 8th minute. Okay, so this can be volume of a gas against time. You see initially there is an increase, and gradually the gradient is getting less steeper, and you can find out the rate is decreasing down. The reaction killed here at 8th minute. Okay, so the steepness of the gradient is also an evidence that how much actually the speed of the reaction. If in other case you change a factor and rate has improved, it means that gradient will be more steeper. Okay, and you have improved further, the gradient will be much steeper. And if the factor has gone negative, your change, it means the gradient basically will be below it, the sluggish. It will take more time. Right here it can finish. Another method to check the rate of the reaction is, that is, we are not having the gas range. In that case, we can use loss in mass method. And loss in mass method, we need a digital balance. Look at the digital balance right here. And we can place a flask and containing the reactants. Suppose in this case, same reactant, maybe zinc and HCl. You'll find out the gas is being produced. The cotton plug ensures that gas escapes out. But the cotton plug ensures that there is no liquid sprinkling out. Okay? Don't write this thing that cotton plug stops the gas. When it stops the gas, then how you can find that rate? It means the mass will not change. Cotton plug let the gas to escape but prevent liquid sprinkling out. You will find out as the reaction is started and the cotton plug is on, then initially the mass is high. Look at that, 180, 176, 72, 68, and 68 is finished right there. Okay, depending on how much reactant you have used. Okay, so this is another representation how you can find out the rate of the reaction using what? The digital balance, the conical flask, and cotton plug. So rates mainly in your syllabus can be monitored this way. Otherwise, there are pressure gauges that can check the amount of the pressure. If the gas is too high, then the pressure gauge is at a certain level that can find the rate. Or the pH changes during a reaction. Initially the pH was acidic, but as the reaction proceeds, it may turn to alkaline. So how much the alkaline pH has appeared in a certain amount of time can monitor the rate. Or even sometime you started with the reaction and the reactions were colorless reactants, but the products got colored. So amount of the time taken for that color to appear, that can tell us about the rate of the reaction. Okay, we call that as colorimetry. So, but initially at your level, mostly these methods are popular. Okay, but general idea you can give, you can find out that if the reaction is proceeding with change in color, you can find out how much time it has taken for a certain color to appear, and then you can find out that how much the rate is produced, how much actually the rate actually is going on. Sometimes we do in a beaker and we mark like this on a piece of paper, and the reactants as they appear initially they were colorless, but as the precipitate is formed, color is formed, the mark disappears. Colorimetry, you can find the rate. Rough measurements, because they will give us an idea how actually you can improve the rate of a reaction. If the precipitate disappears so soon, color appears so quickly, it means your factor is fine, all the optimum rate is being achieved. Okay, you can further improve and you can find out whether it is improving or not. Sometimes the color changes, sometimes the pH changes, pressure changes if the pressure gauges are there. So we can find out basically the rate of the reaction. But basically they may ask you to draw the gas range method, the Pareto simply, and a little calculation and a setup graph, or loss in mass method. You can be asked to draw a rigid balance and conical flask and others. An idea you can weigh. Then initially the mass was high, but with the passage of time the mass is decreasing as the reaction proceeds, and then as the reactant or one of the reactant is used up or both the reactant is used up, depending on if someone limiting reactant it may finish earlier, you'll find out the mass has become constant. Okay, when this says what factor has basically caused the reaction to cease down, we need to be careful what was in excess, and normally it is mentioned in the question. Zinc is in excess, it means HCl is used up. If HCl is in excess, it means zinc is used up. Okay, so we normally take these precautions finding out. So these two main methods to monitor the rate of a reaction, these are methods basically.